Hello, 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 hello. Okay, guys, I think I am audible. Hmm. So, hello everyone, and in this video, we'll be learning about tree traversal techniques. And this is actually a very misunderstood concept in data structures. Actually, there is a confusion. A lot of people learn with this with algorithms, so sometimes it becomes very complex. So, by the way, today we are going to cover the techniques. That is, the first one is BFS, and second one is DFS, breadth first search and depth first search. So we'll see that today. Hi Anshuk, hi Ashmat. Okay, thanks Anshuk. All right. So before moving on, in the live chat, you'll see that we have actually pinned a course, or you can check out the description. So if you want to learn data structures and algorithms together in JavaScript, okay, if you want to learn it in JavaScript and from a beginner level, a very layman level to some advanced level, you can check out this course. If you click that link, you can go to this course. Okay, so this is a paid course, so if you want to purchase it, you can. And before purchasing any course, definitely you must check out the content of that course. So everything is mentioned here. You can check out what will be taught in the course, starting with the introduction, then some basic mathematics which will be required for DSA, not for JavaScript, for DSA. Okay, and then mid magic in JavaScript, then arrays in JavaScript, and a lot of more topics which are required for DSA. Okay, so this actually this course is not made for specifically JavaScript. It covers all concepts of DSA. Okay, so you can check out this one. All right, so now we can continue. Hmm, fine. So, in the live chat, I want to ask how many of you are familiar with these two techniques, BFS and DFS, and can anyone tell me which one should we use? Like, which one is better? All right. So, actually, both are same, like on comparison to power, because both have different purposes. BFS, breadth first search, and DFS, depth first search, simply mean that BFS starts from the top. Okay, if you want to find element nearest from the top, then you'll be using breadth first search. And then if you want to find the elements or do some operations from the bottom, then you will be using depth first search. That means to the depth, from top to the depth. It's like that. Okay, so these two techniques are actually very much misunderstood because of their names and also their methods. So today we'll be actually getting an extreme overview of that, and we'll be writing code in JavaScript. Okay, so I promise that its code will be a lot more easier than any other language, because in if I talk about depth first search, it's very easy. It uses in order, post order, pre order. So there are three types of DFS. And then if I talk about BFS, BFS actually use queue data structure, which is nothing but an array in JavaScript. Okay, so in arrays, if you talk about queue data structure, you will be actually dealing with arrays and their operation. Okay, Anshok is saying in one we use stack and in another we use queue. No, it's not like that. Actually, only in BFS, that is breadth first search, we'll be using queue. Stack isn't used anywhere in this case, because queue is actually based on first in first out, and we'll be using BFS. Yeah, like we'll be using queue in BFS, and in depth first search we don't need any stack or queue, it's just simple code. All right, so we'll see that. And actually I have covered depth first search in the last video, so you can check out my playlist. So if I take you to that playlist, just go to the channel Geeks for Geeks practice, and then you'll find my playlist. So in the playlist section, you'll see that we have covered a lot of topics in data structures. Okay, I'm only talking about data structures in JavaScript, not algorithms, data structures. Okay, so here you can see that a lot of topics are covered, and what I was talking about is you can watch this part 1, okay, to get a more better overview of trees, and also previous videos like introduction to tree and so on, if you don't know something about trees or what is binary search tree. Okay, so now we can continue. So let's start with the definition first. Then I'll clear you with the difference and what's more useful to us. Okay, right. So first of all, you need to know what is traversal. So traversal generally means that you want to visit every part of your data structure. Like suppose you have an array of 10 elements, so you are visiting each element. That's known as traversal. Okay, it's similar in other data structures like linked list, and it's same in trees. Okay, so traversal in general refers to the process of visiting or examining the elements or nodes in data structure. Okay, so you will be visiting and you will be performing some operation on each element of the specific data structure which you want. Okay, so it is a fundamental operation in many data structures including arrays, lists, trees, graphs, and more. Okay, so you can actually traverse in any kind of data structure, and this is actually very important term in your programming journey. Okay, so the purpose of traversal is to access or perform operation on each element or node in the data structure. Okay, so you will be performing operations on each element of your data structure. Suppose your data structure I taught you that suppose your data structure is an array, so you will be performing operation on each element of that array. Okay, suppose there are 10 elements. Okay, so you will be performing operation on 10 elements of that array. Okay, fine. So the order in which the elements are visited can vary depending on the specific traversal algorithm. So I'm not talking about other data structures, but in trees there are actually some specific different traversal algorithms. Okay, so we'll see that one by one, and they actually can cause a specific and significant impact on the behavior and outcome of the traversal. Okay, so it all depends on your purpose, which traversal technique you will use. Okay, so for example, in context of arrays or a list, if I talk about traversal typically involves sequentially accessing each element from beginning to the end or vice versa. Okay, so unidirectional traversal is possible there. Either you will be starting from the starting or you will be starting from the back, okay, from the end. So traversal is something like that in linear data structures like arrays, but in non-linear data structures it's a bit complex. But yeah, still that is very easy. Traversal is easy, but this is important because you need to perform operations, right? So that's why you need to know traversal. Okay, so in the case of trees or graphs, traversal involves visiting each node or vertex in a systematic way. Okay, so there are various traversal algorithms for trees, such as number one is breadth first search and number two is depth first search, so which we have discussed earlier, by the way. So these algorithms determine the order in which the nodes are visited. Okay, so either you will be visiting in a breadth first search way, or either you will be visiting in a depth first search way, which we'll see right now. Okay, so we can actually perform operations like searching, path finding, and data extraction, etc. Okay, so these are some complex tasks done by traversal algorithms. Okay, so tree traversal simply refers to the process of systematically visiting and accessing each node in a tree. Okay, so you can assume this as a tree. Okay, it's actually binary search tree. You can see that each has maximum two children. Okay, so this is actually a binary search tree. So you can see that tree traversal in this case is actually visiting each node of this tree. Okay, so it involves traversing through the nodes in a specific order to perform various operations and gather information from the tree. Okay, so we'll be performing BST, sorry, we'll be performing BFS and DFS, okay, in this same tree. All right, so now comes the main thing, the difference between BFS and DFS. So we'll see that. All right. Okay, so now we can continue. Guys, just a minute, huh? Okay, so now we can continue. So now we'll be looking into the difference between BFS and DFS. So BFS and DFS are two common algorithms that are used for tree traversal. That means visiting each element of each node of the tree in some specific order. Okay, there are actually two orders, BFS and DFS, and in DFS actually we have three different orders, okay, three categories. So we'll be looking into everything one by one. So BFS or breadth first search explores the tree level by level. Okay, first you'll be going to the topmost level, that means the root level, then the second level, then the third level, and something like that. Okay, so it visits all the nodes at current level. That means if suppose in some node there are elements 10, 20, 30, so 10, 20, 30 will be visited, then the next siblings and something like that. Okay, siblings and all the nodes in that level, we'll see that. Okay, so this traversal method actually uses queue data structure to keep track of the nodes to be visited. So we'll keep track what nodes are visited, and we'll just use NQ and DQ techniques, which we'll see, very easy techniques. Okay, don't worry about that. So BFS guarantees that the nodes at the same level are visited before moving downwards, okay, before moving deeper. Okay, so this is very useful for finding shortest path between the nodes or searching for a node closest to the root. Okay, so we'll see that. And similarly, what is DFS? DFS stands for depth first search. DFS explores the tree by going as deep as possible first, and then we'll perform some different kind of orders like in order, pre-order, post-order. So it starts at the root node, visits a child node before visiting any other sibling nodes. DFS can be implemented using different strategies. Okay, so right now I'm just giving you a theory overview, but we'll be seeing the practical overview because that makes more sense. All right, so first of all, I'll tell you what is pre-order. So pre-order DFS visits the current node, then recursively visits the left subtree, and finally it visits the right subtree. Okay, it works something like that. Okay, similarly in order DFS recursively explores the left subtree, visits the current node, okay, whatever is the value or first value of that left subtree, then we'll be visiting recursively the right subtree. Okay, similarly what is post order DFS? Post order recursively explores the left subtree, recursively explores the right subtree, then finally visits the current node. Okay, so DFS is actually useful for searching deeper into the tree, such as finding all the possible paths, detecting cycles, or searching for a specific node or a pattern within the tree. Okay, so both DFS and BFS are actually having their own advantages or applications, and the choice between them actually depends on you, okay, on the situation, on the task which you want. BFS guarantees the shortest path in the terms of edges, while DFS is often more space efficient and can be used to find solutions or traverse through infinite or very large trees. So it is important to note that this is not only for the binary search trees. You can actually use it for any trees with any number of nodes. Okay, it's not only for binary search trees, you can use it for any tree. All right, so now we can continue. So first of all, we'll be looking into DFS. Although we have covered the code part of DFS, but we'll just get a practical example of it. How does it work? And then I'll just again give the code overview for that. Okay, so in DFS, we have three types: pre-order, in order, post order. So just watch this. Okay, it's not too difficult. Just see that pre-order actually reads the data of the node, current node which we are on, and then visits the left subtree. Okay, does the same operation, similarly visit the right subtree. All of these things are actually happening recursively. Okay, similarly in order, in order, we visit left subtree first, then we read the data of that current node, then we'll be visiting the right subtree. Okay, this is also done recursively. And similarly, we have post order. So in post order, we'll be visiting the left subtree first, then right subtree, then we'll be actually reading the data of the node. Please ignore this. Okay, we'll be actually at the end reading the data of the node. Okay, so now what we'll do is we'll be just creating a sample tree and drawing some beautiful diagrams so that you get a better idea of it. All right, so what we'll do is I'll just first open the whiteboard. Okay. It's taking too much time. Let's wait. Hmm. Now it's there. Okay, fine. So let's begin. And I don't actually like the this light mode. So first of all, we'll be changing this. Okay, and format background dark mode. Yeah, now it's fine. All right. So here we'll be creating a very basic tree and we'll be understanding what are the three types which we were looking into. Okay. So first of all, what tree I'm talking about is I'll just draw it. Okay, right away. Fine. All right. So let's pick a pen here. And suppose our tree starts from, we have a few elements here. Suppose the first element will be something, second element will be something, third element will be something. Okay, and so on. We have some, suppose we have two more childs for that. Okay, okay, I think this is fine, and let's join them. Okay, this is actually fun. I can actually start drawing here. So here you can see this is a very basic tree, and suppose the first element is 12 again, and second element here is 7, 17. Okay, and suppose the last elements are 5 and 9. Suppose this is my tree. Okay, this is my tree. I have created a tree like this because this is a binary search tree. This is a BST. Okay, by the way, if you don't know what this tree is, it's a binary search tree. Here you can see the lesser elements are on the left side, bigger elements are on the right side. Okay, so you can actually perform BFS and DFS in any kind of tree, but for now, for this tutorial, we'll be referring BST, okay, binary search tree, to perform BFS and DFS traversals. Okay, so here what do we need to do is, first of all, we'll be performing pre-order traversal. Okay, so what does pre-order traversal do is, I can simply write pre order here. Okay, pre-order traversal will simply do, first of all you need to visit the route. Okay, so this is actually the route. So first of all you will be going to the route, that is 12. Okay, so then first of all you will go to the left side. Okay, left subtree. Okay, so here what you will do is, I'll just change the pen. So first of all we are going to the left side. Okay, this is 7. Okay, that means we'll be going to 7. Okay, similarly we'll be going to we'll be going to 5 after that. Okay, similarly we'll be going to the deepest left side. Okay, so in our case 5 is the deepest, so now we are actually on 5. Okay, now the left deepest is covered, right? Now after that we'll be covering all the right sides. Okay, that means right side of 5 is actually 9, similarly right side of 7 will be 17, and so on. Okay, so suppose this tree is too big, so you can actually cover all the right side that way. Okay, so now I'll just say that simply write 9 here. Okay, we'll be visiting 9 for 5, and then similarly 17. Okay, so you can see first we okay, so here you can actually see in the pre-order we read the data of the node first, that is 12. Okay, then we visit the left side, again we read the data, again we visited the left side, again we read the data. When we reach the leftmost side, then we start visiting the right side. Okay, from the bottom we start visiting the right side. So right side of 5 was 9. Okay, similarly for 7 was 17, and so on. Okay, so first we read the data for the root, then we visited the left side, again we read the data, then we again visited the left side, again we read the data, and then we start visiting the right side. Okay, right side is actually in opposite order, that is backtracking. So here you can see we visited 5, after that we started with 9, then we started with 17. Okay, it's like that. All right, so this is actually pre-order. Now we'll be looking into post order, so you can actually ignore my handwriting, I'm not so proficient with this whiteboard. Okay, so now we'll be looking into post order. So post order. All right, so what does post order do? Okay, first of all, I'll just separate it out. Okay, my bad. Again. Yes, fine. Okay, so now we'll be looking into post order. So for post order, what I'll do is I'll just change the ink. Yeah, fine. So for post order, first of all, we need to visit the left subtree. Okay, so we need to visit the left subtree. So how does it actually work is, actually before visiting the post order, we'll be actually visiting the in order. Okay, because yeah, I like to do that first. Okay, so what I'll do is I'll be visiting in order. I'll be teaching you in order first. Okay, so what does in order do? Okay, so what does in order do? In order simply does one thing. Okay, in order simply does one thing. We'll be visiting the left side first. Okay, the left side, bottom left side. Okay, extreme bottom. Okay, extreme depth. Okay, so what we'll do is we'll be just first of all going to the extreme left. Okay, that is the first element will be 5 in this case. Okay, so right now we have 5 here. Okay, similarly after this we'll be covering the before one. Okay, before one is 7. Okay, so we'll be going to 7. Similarly before that is what? Okay, so let me tell you what's the basic criteria of in order. First we visited the left side. Okay, first we visited the left side, then we read the data. Okay, then we visited the parent node. Okay, whatever is the parent node, we'll be visiting the parent node. Then we visit the right side of that parent. Okay, it's like that. First you visited 5, then 7, then 9. Okay, it's like that. It's it's like 5, 7, and then you visited 9. Okay, then you visited 9. Okay, now you are here. So from 7 you visited 9. All right, fine. Now after this, again you will be visiting the next parent. Okay, all the three are covered. Now the parent of 7 is actually 12, so now you will be visiting 12. Okay, so now you will be visiting 12. Okay, now you have 12 here. I'll just separate these by commas. Fine. Then you will be visiting the right side. Okay, it works actually like that. So this is in order. Okay. Yeah. After this, we'll be learning about the next one, that is post order. Okay, so post order is actually very easy. Post order simply means that first you will visit the left side, then right side, then top. Okay, so post order simply means that first of all, again, you will be starting with 5. Okay, you will be starting with 5. So again, we are on the left side. That means we'll be starting with 5. So I'll just change the ink again. Okay, so again, you will be starting with 5. Then you will be visiting the right side. First you are in the leftmost, okay, depth. Okay, leftmost depth, you are on 5. Then you will be visiting the right child if it's there. Okay, now you have covered 9. So first you will be covering 5 here. Okay, 5 is covered. Then 9 is covered. Okay, then what is covered? Then you will be actually visiting the parent. Okay, so it's like left, right, parent. So now you will be visiting the parent. So now you are actually here. So again, you visit 17. Now again, you will compare what is the right side of it. So you can see that 7 and then we have 17. So now we'll be visiting 17. Just know that they must be same child. That means they must be siblings. 7 and 17 are actually siblings. Okay, they are of same parents. Okay, they are of same parent. That means 12. So now 17 is covered from 7. 17 is covered. Now we'll be visiting 12. So this is actually post order, and I know you might be thinking, why are we visiting in such strange order? But actually, it has some purpose. Okay, so just follow this path, and now I think this is fine. Okay, so 17 and the last one is actually 12. So now I think I have covered everyone. Okay, so you can see this is actually pre-order, this is in order, this is post order. So these are the three types which we wanted to know in, yeah, dark mode supremacy. Okay, so these were the three types which I wanted to cover. So please, if you have any doubts, you can still ask me again for these three: pre-order, in order, and post order. Actually, there is nothing to learn anything about it. You just know this, like you can just see this. The order is actually pretty much confusing. First of all, when I tried to learn it first, it was actually confusing, but later on I just found a way. Okay, simply, in pre-order, first of all, you will be starting with the parent. Okay, you will be starting with the parent, whatever is the parent. Initially the parent will always be root. Okay, then you will be visiting its leftmost side. Okay, left, 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 it's like that. Okay, so you will be visiting left, left, and so on. Okay, now all the lefts are covered. You can see 12, 7, 5, all the lefts are covered. Now you will be starting from right. Okay, right bottom. That's it. Okay, so here bottom tak, here bottom, we need to visit to bottom. Let's change this. Okay, yeah, it's understood. Okay, so you need to visit till bottom. So then from bottom you will be starting from the right side, that is 9 and 17. So it works like that. And here what do you do is, in order, you are actually visiting from 5. That means the leftmost side, then its parent, then right side. Similarly, leftmost side is 7. 7 is already covered. You'll be visiting its parent, then right side, and so on. Okay, so left, bottom. Okay, extreme left bottom, you will be starting from here. Okay, then you will be visiting its parent. Okay, its parent, then you will be visiting its right. Okay, okay, then again you are at right, okay, you are at right side. Again you will be visiting the parent again, that is 7 is again the parent. You will be visiting the topmost parent, because 7 is already covered. You will be visiting the topmost parent, whatever is the parent of 7 at that time. 12, then 17, it's like that. Okay, left, left, parent, right, left, parent, right, it's like that. Okay, then in post order, it's actually like post order, you'll be first visiting 5, then right side, again you'll be visiting their parent, again the right side, it's like that. Okay, so left, right parent. Okay, I think it wasn't visible, so what I'll do is I'll just write it here. All right, so here you will be simply visiting left, right, and last one is parent. It's like that. So things are actually happening recursively. It's like that. Okay, things are happening again and again until everything is covered. Okay, so this is actually pre-order, in order, post order. So we have actually covered this in the coding part, so please watch the part 1 of BST, which is available in the playlist of this channel. Okay, so I'll just show you the code so that we can understand what we have covered, and I'll just open VS Code again. So we were actually writing our code here. Okay, so you can actually see this in the last video. We have created a basic tree. Okay, this is actually a very basic tree, and here you can see that we have covered pre-order, in order, and post orders. Okay, so it's very same. You can see, first of all, I just printed the value. Okay, whatever is the value, then we visited the left side, then we visited the right side. This is pre-order. Okay, we covered this. Similarly, we have in order. In order has, first we visit the left side, then the parent, then the right side. Okay, it's like that. Again, we'll be visiting in post order, we'll be visiting the left side, then right side, then the parent. Okay, it's like that. So you can see that this is actually taught in the last video, so you can see that video for the code part. The video is actually BST part 1, and you will actually find that in the Geeks for Geeks practice channel. Let me show you that. Okay, so if you visit Geeks for Geeks practice channel, in the playlist section, you will find this playlist, data structures using JavaScript. Here you'll see that we have part 1, operations in BST part 1. So you can see that I have covered the coding part of this depth first search there. Okay, so you can see in order, pre-order, and post order there. Okay, fine. All right. Okay, so now we'll continue. So this was actually pre-order, in order, and post order. The code is very same as the explanation. You can see that. Okay, so if you know trees, you have watched my previous video, you will get this code. Okay, so now we can continue with another one, that is breadth first search. We have covered depth first search. Now we'll be continuing with breadth first search. Okay, we'll be continuing with breadth first search. So what is BFS actually? So BFS is, again, stands for breadth first search, is a graph traversal algorithm that explores a graph or a tree in breadthward motion. That means from top level completed, then second level completed, then third level completed. It's like that. Okay, so it starts in a given source, vertex, or node, or parent, and visits all its neighboring vertices. That means top. Okay, then again first level, then second level. It's like that. Okay, so you'll be visiting each node at each level. Okay, so we'll see that this algorithm uses a queue data structure to keep track of the vertices to be visited. What is queue? Okay, now you might be wondering what is queue. So queue is actually a data structure which we'll be covering later on. We haven't covered right now, but for simplicity, I'll just tell you a very basic definition for it. So queue is actually a linear data structure that follows the first in, first out principle. Okay, meaning that the element added first to it will be removed first. Okay, so the two main operations associated with queues are enqueuing and dequeuing. So enqueuing simply means adding data to queue, and dequeuing simply means removing data from queue. Okay, so we'll be performing that. So queue simply means, suppose I have elements 10, 11, 12, 13. Okay, I added these in the same order. Okay, so I added these elements in the same order, 10, 11, 12, 13. So if I follow queue architecture, that means I'll be removing the first element which I added. That means first I'll remove 10, 10 will be removed, then 11 will be removed, and 12 will be removed, and 13 will be removed. So queue actually follows FIFO. That means first in, first out. Okay, so this is very basic definition. I won't be teaching queue right now in much detail because we'll be creating separate videos for that. But today we'll be just using a simple example for that. Okay, so what is enqueuing? I told you enqueuing is like adding data at the end. Like suppose you have an array 10, 11, 12, 13. Okay, you want to add 14 to the array. If you add this element 14 at the end of the array, it simply means you are enqueuing. Okay, so if I talk about in the terms of arrays, because in JavaScript we use array data structure for performing queue operations. Okay, so if I talk about arrays, if you add any element in the end of the array, that simply means enqueuing. Okay, and dequeuing simply means that removing the first element from the array. First element was 10, so you are removing first element. Okay, so let me just give you an example so that you get a better idea of that. All right, fine. Hmm. Okay, so now we can continue. Okay, so first of all, I'll give you an example of an array. Suppose you have an array. Okay, suppose you have an array like this. So this is an array, and you can actually consider as a, sorry, not a stack, you can actually consider it as a queue. Okay, queue simply means, suppose I have elements 10, 10, 11, 12, 13. Okay, we have added 4 elements. Suppose I add 10 as the first index. Okay, that means the 0th index of this array. I'm sorry, 0th index. So here you can see in the 0th index we have 10 here. Okay, we have 10 here. Similarly, in the first index I add 11. So what's actually happening here? I'm actually adding elements one by one. Okay, that means first element is added, second element is added. What I'm doing is I'm enqueuing. This is called enqueuing. I'm adding elements at the end. Okay, whatever is the latest index, I'm adding there. Okay, first 0 is empty, so I'm adding element to 0. Now 1 is empty, so now I am adding the element to first index. Okay, it works like that. Similarly, you will be adding, you will be enqueuing element at the second index, that is 12. Okay, that is 13, and so on. You will be adding elements like that. So this is known as enqueuing. What is dequeuing? You actually remove the first element. Okay, you actually remove this first element. So what will happen is this will actually be removed. This first element will be removed. I have dequeued this. Okay, and I actually will store this value somewhere. Okay, I'll actually store this value somewhere. That actually means that will actually remind me that I have removed 10, so I've actually stored it somewhere. Similarly, I have remembered it. Similarly, we have 11. Okay, now what will happen is the 0th index of the array will be actually 11. Okay, will be actually 11. So now it will become the 0th index, and 12 will become the first index, and so on. Okay, similarly, if I perform dequeue operation on this array again, so again you'll see that we have removed the first element again. That means the 0th index again for this array. Again, what will happen is, again you have this as the 0th index, and so on. So it works like that. So enqueuing is adding element at the end, dequeuing is removing element from the front. All right, so I hope it's understood. Now we'll be using the same logic in BFS, that is breadth first search. So for BFS, again we'll be using the same diagram. Okay, again we'll be using the same diagram. So here you can see we have 12, 7, 17, 5, 9. Okay, fine. So let's draw this. So we have elements here 12. Okay, we have elements here 12, and circle is fine. Okay, 12, 7, and 17. Okay, and then there were 5, again 5 here. Okay, and then 9 here. Okay, fine, fine. So I think this tree is actually fine. And now what I'm trying to say, if I am performing BFS here, okay, so if I am talking about BFS, breadth first search, what must actually happen is I'll be visiting the first level. Okay, first level is what? 12. Okay, I'll be visiting the first level, that is 12. So first level has 12. Okay, now second level has what? 7 and 17. Okay, so this traversal technique actually uses level by level approach, 7 and 17. Now we have what elements? We have 5 and 9. So we'll cover 5 and 9. That's what BFS is, visiting the tree level by level. Okay, 12, 7, 17, 5 and 9. It's like that. Okay, so suppose 7 also had a child. Suppose 7 had a child like 19. Since it's greater, it will be on right side. Okay, so after 5 9 you will actually cover 19, then the next child's of any if possible. Okay, so it's like that. So level by level, okay, you are covering things like that. All right, fine. So now what we'll do is we'll be actually understanding how NQ and DQ is working here, how we use NQ and DQ here. Okay, so first of all, I'll just make it normal. Fine. Okay, so now we'll see first of all what will happen. Okay, so first of all, 10 actually here you can see we have element 12, 7, 17, 5, 9, and also we'll just remove this 19 because we don't have it here. Okay, so here you can see first element will be our root element. Always first element will be our root element. Okay, so suppose you can assume this as our array. You can assume this as our array. Okay, now what actually happens here is you have added an element, first element, whatever is the first element, you will be adding it here. Okay, so what is the first element? Your first element is 12. Okay, that means in the 0th index of this array you have added 12. Fine, 12 is added here. Now what will happen is you'll remember this value. Okay, first you add this value. Okay, then you remember this value. Okay, you remember this value. What you will do is you will dequeue it again. Instantly you will dequeue it. Okay, you'll add it first, then you'll dequeue it. Now what will happen is you'll find its child. You will find its child. So its childs are actually 5. What were its child? No, not this 5. So its childs were actually 7 and 17. Okay, so 7, 7 and 17. Remember, your flow must be from left to right side. Okay, you are actually traversing, first of all this is covered, then left side, right side, left side, right, and so on. Okay, so from left to right you are actually writing elements from left to right. Okay, so what will happen is once 12 is removed, our stack or our array will become empty. Okay, will become empty. That means dequeue operation has been performed. Now we'll be adding the two childs which we have obtained in the same order, that means 7, and then we'll be adding 17. Fine. Okay, so also one more thing, let's suppose we remember 12 here. Okay, so 12 is suppose remembered. Okay, so here you can see now we have 7 and 17. Now in the 0th index, what do we have? We have 7, right? We have 7. So we'll dequeue 7. Okay, we'll remove 7. We'll dequeue 7. So NQ is actually working like first you have added 7, then you have added 17. Now DQ is actually like we are removing 7. So 7 actually has childs what? 5 and 9. Okay, 7 has childs 5 and 9. So what will happen is now 7 will be removed. Okay, 7 will be removed and 17 will be shifted. Okay, are you getting my point? 17 will be now shifted. Okay, fine. So 17 is actually now shifted. So you have 17 here. I'll just write it here. Okay, so now 17 is here. 17 is actually shifted to the 0th index. Okay, and 7 is removed. Now what will happen is you have two new childs, 5 and 9. So in the same order, just add 5 and 9. Okay, and now this will happen. I think I must start writing from here. Okay, so 12 is actually remembered now. Now 12 and 7 are remembered. Fine. 12 and 7 are remembered. Similarly, if I talk about 17, 17 does not have any child, right? 17 does not have any child, so you can just simply remove 17. If it does not have any child, you can simply remove it. Okay, so it will be removed and no childs will be added. So now what will happen is 5 and 9 will be shifted. Okay, again, what will be remembered? 12, 7, 17 will be remembered. Okay, I think okay, I think it's visible enough. Fine. So now 12, 7, 17 are here. Okay. Similarly, if I talk about again the zeroth index has 5, 5 will be removed. Okay. Now what will be remembered? Now what will be remembered is 12, 7, 17, and what's next? What's next is 5. Okay. So now at the end, our Q has shifted 9 here. Okay, so 9 will be in zeroth index and no other elements will be there. Again, 9 will be removed. Okay, since it's the first element, it will be removed. Now we have this order 12, 7, 17, 5, and last one is 9. So you can actually see this order is here. Okay, fine. So this order is actually here. So you can see this will be actually the method which we'll be using. Okay, so how can we actually get the first element and remove that? For that, we'll be actually using the shift operation which is available in arrays. So we'll see that. Okay, so let's go to the coding part. So I'll just okay, so now what I'll do is I'll just open VS Code here, and here you can see this was the code which we have written in part 1, so I won't be repeating that. And from here, there is a very basic code part which we write for this. That is BFS. Okay, so we'll be writing BFS. Okay, BFS traversal. So here you can just call BFS traversal as level order. Okay, in DFS we had pre-order, in order, and post order. Similarly, BFS can be also known as level order. Okay, so I can simply write level order or BFS order. Any will work. So if I write BFS order, okay, inside this you can provide the root element, although you can simply get the root element. If you are working on this, you can actually call this the root and it will work, but I'm providing root element separately. Okay, so you are providing root element, you have the root element of the tree where you want to start. Okay, now you have an empty queue. Initially you will be having an empty queue, so for that we will be using arrays. Okay, for queues in JavaScript we use arrays. Okay, so first of all we'll be pushing the first element. Okay, right, we'll be pushing the first element, so we can simply type q dot push, and now first element will be pushed. That means in the sorry that means in the queue we have first element 12 and rest everything is empty in the array. Okay, fine, rest everything is empty in the array. Now what will happen is we'll simply say until queue is empty, until queue is empty, do one operation, that is while queue dot length is greater than 0. Okay, is greater than 0. What will happen is I'll simply say, first of all, perform the shift operation. That means remove the first element and remember it. Okay, it actually means remove the first element, that is in this case 12 is removed and it's remembered. Okay, it's remembered. So what will happen is I'll just say that let whatever node you are removing, you are remembering it, so I'm just storing it in the variable. Okay, so you can simply say q dot shift. Okay, shift operation simply means remove the zeroth index. Okay, and it will return the zeroth index. Okay, it simply does, it will remove the zeroth index, that is value 12, and it will be stored in the node. Okay, it will also be stored in the node, so node will now be equal to 12. Okay, now node also knows what are the childs of 12. Fine, node also knows what are the childs of 12, because if you print root actually contains all the information about 12. Okay, it does not only contain the number 12, it actually contains information about what are the childs, and like that, that means root dot left and root dot right, and in this case node dot left, node dot right. Okay, so here what I'll do is I'll simply say that console dot log node dot data. This will simply print the data of the node, whatever is present. Okay, so we'll see that, and I'll just say that if left child is available, that means it's not null. Okay, if it's not null, we have simply declared initially the child as null, and if child is available, it won't be null. Okay, so I'll simply say left as no, not equal to null. And this null process actually is defined in the last video. You can check out, I think yeah, you can see that actually we have covered this in the last video, so you can check out. And we have created a node here. Here you can see that we have created the left as null and right as null, so it was covered in last video. You can check that out. Okay, now again here we have simply said that if the whatever is the node has left child, then simply push the left child in that, okay, in that array. Okay, so I'll simply say q dot push and whatever is the left child. So what is the left child? Okay, simply left child will be in this case, okay, what was the example which we are looking? Yeah, left child in this case will be actually 7. Okay, 7. And similarly I'll say what was the right child? We still remember, okay, we are only adding one element. That means now 12 is removed, we have 7 as the 0th index. Again we have one more element, that is whatever was the right child. If right child is there, it will be added. Okay, so right child is 17, it will be added. So now our array is actually like 7 and 17, it's like that. Okay, now what will happen is, again this while loop will run. Okay, while loop will run again, whatever is in the 0th index will be shifted, you can see will be shifted, and its child are added to the stack. Okay, and the same process goes on and on, it works like that. So this is actually the process which happens in BFS. Okay, that means first you are at the root element, then its left child, then its right child, then left child's left child, right child, left child, right child. It works like that. Okay, I hope now it's understood. And this was the very basic code of breadth first search, and this was the very basic code of depth first search. Depth first search was actually of three types: pre-order, in-order, post-order. And BFS, breadth first search, was actually of one type, that is, you can actually call it as level order also. Okay, instead of this you can call it as level order. So now let's run this first so that you get a better idea. So I'll just remove it. I'll simply say my tree dot bfs order. Inside this you'll be providing the root value, because we are calling the root value here. Okay, we are calling the root value here. Okay, fine. So now if I just run this on terminal, and it's actually referring the example which we have previously used, 12 7 17 5 9, which we were using till now. Okay, so I'll simply print this. I'll simply call this, so node script1.js, and now you can see we have the order 12 7 17 5 9. Okay, it's the correct order. So this was the BFS, and previously we have covered the DFS part also. Okay, so I hope you understood this, and if you have any doubts you can still ask me in the live chat. Okay. So before ending this video, in the description or in the live chat, you can find a course provided by Geeks for Geeks, that's for data structures and algorithms using JavaScript. So if you want to learn data structures and algorithms in JavaScript, you can check out this course. This is a paid course, and in the course content you can see what all things will be taught here. So if you are interested, you can go for this course, and it will take you from beginner level to advanced level in DSA with JavaScript. Okay, concepts are same, but it's taught in JavaScript. All right, so I hope this video was fruitful for you. If you have any doubts, you can ask me in the live chat, or you can message me on Instagram at the rate Harshal_3011. Okay, this is my Instagram username, or you can message me on LinkedIn, Harshal Jain. Okay, so I hope you understood this video, and I will see you in the next one. In the next one will be actually covering the second part of breadth first binary tree. Okay, we'll be covering the second part of binary tree. So we'll see you in the next video. Till then, see you, have a good day. Bye bye.